part of the problem here. Good, that one's good.
Should be 33.
Yes.
Okay.
All right. Okay. So you said 3 and 4 on the other side?
Mm-hmm.
All right, let's look at 4 first. 4 is actually more straightforward than 3. You're multiplying fractions. And I think what gets confusing is the kind of the mixture of, okay, we got fractions and then adding fractions, but you just multiply the top numbers and
Mm-hmm.
you multiply the bottom numbers.
Okay. So 1 times 1 and 4 times 3,
Yeah.
so 1 over 12. So 12. Or just 1 over 12.
So where you run into issues, let's say it's 3/4 times 2/3. You can either do what we just did, or you can pre-reduce,
Mm-hmm.
or you can multiply and then reduce.
Mm-hmm. I think the way that she wants us to do is probably just do this problem, then reduce.
Okay.
So, okay. What's that? 2, 1/3. That'd be the answer?
Did you get 6/12?
Yes.
Okay, so what did you divide the top and bottom by?
I divided the top one by 3 and the bottom one by 3.
Okay, you should, okay, like that's fine. It does work. You actually want to always start with 2.
Oh, okay. So it would
Okay.
be 3, 6. Okay.
And then
Actually,
and
maybe
then
I do
okay,
that because that's what I have on my paper.
then
Is the
you try 3. Does work.
So 1/3.
Nope. 6 divided by 3
Oh,
is
6 divided by 3 is 2.
okay.
So 1/2.
Yeah.
Okay.
Okay. So we'll do some more of those at some
Number
point.
three.
We'll get to 3 here in just a moment, but a number like 2 can be written as 2 divided by 1. So
Mm-hmm.
any number
So
can be
6.
divided by 1.
So then it would be 60 over 5 if you did just the multiplication way like
Right.
that.
Now you have the option though, you have the option to pre-reduce. Now you can do this, that's fine, but then you're literally saying 60 divided by 5,
Hmm. 12.
which is 12.
Yeah.
Now, what if you pre-reduce to start? What's 30 divided by 5?
Would be it would be sorry, 6. So
6. 2 times 6 is 12. So yeah, these are the same.
mhm.
Now it doesn't
Yeah.
always work out like that, but it could. So let's say it's 3 times 42 over 7.
Mm. Okay, so you could turn it into 3 over 1 and 42 times 3. be 126 over 7. And then could that be reduced? What would you do? Hmm. So what would you do?
Yeah, okay, so it's really important that you pre-reduce. That was the whole
Oh, okay.
point here. You really want to,
So
because
42.
you're
That's
going to, you're
really
going
high
to get,
numbers. Yeah.
yeah, and so like this isn't taught, but you really want to divide before you multiply, if you can. If you can. I mean, you know, not always possible, but so then it's 3 times 6, which is 18. And
Mhm.
so 3 times 6 is 18. Like that. Okay, let's try another one here. Let's say it's 1/2 39 divided by 3.
Mhm. Um, hmm. So if you pre-reduced that, would it be 13 over 3?
You're dividing both by 3.
Oh, so
So
13 over
it's,
1.
yes, or just 13. So it's half of 13 over 1, which is
Okay, so it would be 13 divided by 1/2. So half
or
of
13. So
13.
13 over 2, which is okay.
Okay.
All right. So what else did you have on here? Um, yeah, so 5 is correct, 6 is correct. The 50%, that's good. Uh, last one, 10. 10 we gotta look at. So the thing with 10 that I don't see in all the others is I see some work. Do you remember what this line above the 5, what that
Means it's
means?
repeated forever, right?
Right. So it might be good to write a few of those out.
Oh, so when you round?
You don't round, it's like you go until there's a different digit. So see how the first one is the same,
Mm-hmm.
and then there'd be a 0 here.
Mm-hmm.
So is the second one the same?
No.
No, it's a 5, and you're like, all right, which is bigger? 5, oops. 5 or 0, which is bigger? Which one is larger,
Oh,
5 or
5 is larger.
Yeah, so it's actually the other direction.
Huh, okay. Good to know.
I mean, so what I'm seeing here is just an effort here to really get like solid on fractions and decimals and things like that. Um,
Okay.
so anything else here that you want to cover that
I don't think so. No.
um, well, we got some time left, so we should spend a little bit more time on fractions, decimals, and percents. If you're okay with that,
Okay.
happy to kind of work through that. So let's look at a few more here. Let's look at like 2/3 and 0.6. You know, what goes in there.
Um, so would you turn the fraction into a decimal or the decimal into a fraction?
Yeah, so normally you go to a decimal, and if you can, this would be good to put into a decimal. But if you can't, or you're not sure, then you got to go the other way. You got to go this to a fraction.
Okay. Would I think the 2/3 would be larger.
Great. But how did you do that? Did you convert this to a decimal? Did you convert 0.6 to a fraction? What did you do?
Well, I converted the 2/3 into a decimal.
Okay, what did you get as a decimal for that?
Um, so, hey, wait, never mind. Maybe I did. I guess I just got it mixed up with another note.
Yeah, I mean, you got to be careful with me. If
Yeah.
you say you did something, I'm going to ask you what do you got? Because
Yeah, I know. I
that's
thought
fine.
I did it, but I was looking at a different. I have it was two-sided paper, so I was looking at the wrong page. Well, would you can? I was thinking that it's
So August, it doesn't matter to me which way you go, and I'm not trying to corner you or anything. I think you should convert this to a fraction.
yeah. I'm trying to figure out would that be a 60 over 100?
Okay, so what is that? So what does that maybe reduce to?
You turn into 6/10.
Okay, and does that reduce further?
It would be 3/5.
Good. Okay, so our new problem is 2/3 and 3/5. You have to make a common denominator.
Okay. 15.
Okay, so do that and see which one is larger, which one is
Okay.
smaller.
So yeah, the 2/3 would be larger because it would become 10/15 and then 9/15. Right?
Okay.
So only 10/15 would be larger.
All right. So there you go. This one is larger.
Mhm.
Very good. Okay. Let me throw, I've got some other ones up here for us to look at that could be good. Um, so this is really four problems in one. Um, it says which statement is true, and you really need to look at each of them. Like, is that true? Is that true? Is that true? Is that true? So let's just do them one by one. I want you to tell me if A is true or
Okay.
false. And you probably want to go to a decimal for that.
Mm, it would be false. The first one.
This is 0.59, so that is
Yeah.
false. So we know it's not A. What about B?
Mm-hmm. That's true. 0.75 and 0.8. Would that be a zero after that?
0.75, 0.80.
Oh wait, no. It would be the 0.8. Zero. That's false as well.
Okay, I got a C.
That's false as well.
So this is 0.59.
Mm-hmm. No, 0.53.
So we know that this is true. But why?
Mm-hmm.
Why is this true? I want you to somehow decide on your own. Why is that one true?
Why would it be true? Because oh wait, 'cause percentage
So you
method
yeah, you've
versus
either got
dollar
to convert
percents.
to yeah, either go one way or the other.
So that'd be 0.0059.
0.059.
Zero point
I
zero
probably I probably would
zero.
have said to go to a percent.
Okay.
I think that would have been easier.
Yeah.
You can do it either way.
Okay. Okay.
All right, let's try another one. Um, Go ahead and give this a try, please.
Hmm. Would it be? I'm not sure. Would it be G? I'm not sure if that's true though.
Right. Have you eliminated some, or are you
Well,
just you're just
I
going?
know that F is not because it's just smaller.
Wait, what is
Three,
smaller? Three-
the numbers on the side, the not the whole
Right,
number.
but how do you know that 3/4? how did you decide, this relationship between 4/5 and 3/4? Did you make a common
Well,
denominator? And you can't just say the numbers are small. That's not a good enough explanation. You really want to make a common
yeah.
denominator.
Well, I guess that could work. Because it'd be 1, 15, 20. Wait, what? Oh, never mind. Oh, that's what about that. Yeah. 15 is smaller. It's that could work, I guess.
So when you get this fraction, it is this direction.
Mhm.
You agree? 16/20 greater than 15/20.
So it need to be. It wouldn't be F.
So it's not that, but I mean, you got to know why. Like, yeah,
Okay.
it's not good enough to say, yeah, it's you gotta an explanation.
Okay.
So let's take a look at the next one there. 50/10. Maybe reduce that. Maybe see what that reduces to.
Yeah, wouldn't it just become 5 whole?
Five whole. So how does that compare to,
It
if you need
would
to,
be
just
smaller because it's 5 whole and the 4/5.
yep. So that one's out.
5, 8. Not sure. So would it
You're saying for H, you're not sure about?
be,
What is 4/5 as a decimal? Or what is 0.8 as a fraction?
well, 4/5 would be 0.4?
How did you come up with that?
5.4. So that
So
H would work, I guess, because 5 point, well, you could turn it into 40 over 500. Like,
You could, but okay. So are you remember you want to go to 100 typically.
okay, so how many you get two? So it'll be 20. So 5 times 20 is 100. 4 times 20 is 80. So it would be 0.8. So they would be equal?
Yeah. So we know it's not that one, therefore it
Yeah.
must be that one.
Mhm.
And you're kind of noticing a pattern, but
Mhm.
that's okay. All right. This one might be unfair because you got to count blocks, but I think you can do it. These are nice enough pictures.
It's created area. It would be C, 47%.
Okay, how did you come up with that? So what you did.
If it's a 10 by 10, so it's 100 squares. So the first row in the shaded is 10%, then it'd be 20%, then 30%. Um,
Like that. So you get rid of the ones that's definitely not those, right?
yeah,
And so
and it would just be that. Or you could just do the math is if you put down, you took that corner chunk and just slid it over, then added one more to that, it would be 40%, and counted the rest of the remainder, it would be 47%.
okay. If I say ascending order, do you know what that means?
Not really.
So ascending is like increasing order.
Oh yeah.
So small to large. And I always
Mhm.
think about an airplane, ascending, increase, or if you prefer, maybe the captain gets the plane, we're descending, that's the other direction.
Mhm.
Okay. So I want you to put the following into ascending order.
Mhm.
All right. 4/5, 0.6, and 75%.
Okay.
Right. Which means you probably need to put them either all into a decimal or all into a
Okay.
fraction or
I'll probably
something
just do
like,
a decimal.
yeah.
So it would be 0, save. So I think it would go um 0.6, then 4/5, then 75%.
You said, so is this your order 0.6, 4/5, and then 75%?
Yes.
Okay. So you said you converted all these to decimals.
Mm-hmm.
What is the decimal for 4/5?
4/5 would be 0.8.
Okay. And what is the decimal for 75%?
Um 0.75.
Okay. So let's try that one more time.
Mhm.
Which one is the smallest? Which one is the biggest?
Oh,
0.6 definitely the smallest. Which one
yeah.
is the biggest though?
Wouldn't that be the 0.75?
You're comparing 0.8 and 0.75. Are you choosing this one because it has more digits?
Oh, wait, no. Because if you had the zero, and so it would be 0.6, 0.75, 0.8. Okay, that makes more sense now.
Okay. So which is the largest?
So it would be 0.8.
Which is 4/5.
Mhm.
All right, good. All right, so let's close out here with one more here. So our lessons will be somewhere between 35 and 40 minutes, depending on what we need, but we'll try one more here.
Okay. Oh, can't hear you.
Yeah, currently I'm muted. Sorry about that.
There we go. Okay, so would be A is true.
All right, very good. All right, so we're gonna stop there for today. Good job. Um, so we've got another lesson on Thursday at the same time at